Assalamualaikum and a very good morning to my panels. I am Muhammad Haikal Syahmi, FIB student under my supervisor, Prof. R. Dr. Jamaluddin bin Mahmud. My student number is 20196544138 and my FIB title is Failure Analysis and Lamination Scheme Optimization of Hybrid Composite Laminates under Transverse Sinusoidal Load. Basically, to design a composite structure, it is important to understand the deformation and failure behavior of composite material. Therefore, by using a computational technique, it will explore the deformation and failure behavior of hybrid composite laminate under transverse sinusoidal load. Therefore, to set up key specimen parameter correctly, design of experiment DOE will be used. Then, the output and outcome from the simulation will be compared and analyzed. Along this FYP, tooling software will be used, which is ANSYS FADL to do simulation, and design of experiment DOE will to set up the accurate parameters. As introduction for my FYP, composite material is combination of two or more material on macroscopic scale to form a useful third material as shown in the video below. Even though the composite material have been widely used in multiple of applications because of their tolerable features, but to understand their failure behavior is always challenging. To study their behavior, experiments are the most effective and realistic way to learn. But making composite laminates simple is a bit costly. Hybrid composite laminates are even more costly to make than regular composite laminates since sample preparation is more difficult. Therefore, commercial software or finite element analysis (FEA) is used to solve and learn about their behavior. Furthermore, the capability and applicability of ANSYS built-in failure criteria function have been investigated and confirmed. Some of the common applications of composite material are aircraft, racing car body, defense sector, and some energy sector. Composite material are widely used more than 60 years. It started from when Mongols invented their first composite bolt as their weapon. Then, wood and straw used to construct building blocks by Egypt and Mesopotamia. Until now, due to their specific properties such as high strength, stiffness, extended fatigue life, low density, and flexible to construct intended function. However, their properties still depend on the boundaries condition and fiber orientation. The main problem statement that bring to my FRB study is first, the experiment method to study the behavior of the composite laminate material is expensive, as they require multiple sets of laminated composite material to understand their behavior. Moreover, there are lack of information related to the sandwich laminated composite material. Then, third is some may still doubt the accuracy of the computational method to do analysis. The result obtained should be proven with the approximate result from the previous studies. Lastly, there are a question is that a great combination graphite and glass to reduce the cost of material, but the strength and its lightweight characteristic is maintained. The objective for this project is to develop an accurate finite element model of composite laminate under transverse sinusoidal load. In addition, to analyze the effect of laminate scheme, plate thickness, and hybridization to the failure behavior of hybrid composite laminate under transverse sinusoidal load. Lastly, is to determine the optimum parameter using response surface methodology (RSM) and design of experiment (DOE). Scope for my FYP is their specific lamination scheme. First is normal with 0 degrees, then anti-symmetric cross-ply and symmetric cross-ply of lamination scheme. Then their thickness is referring to the aspect ratio, which is S equal to length divided by height. Their aspect ratio will be used is 5, 10, 20, 50, and 100. Material is laminated to graphite, glass, and hybrid, which is sandwich laminated, the combination of two materials. Result will be referred to if pressure applied until the material fails. As mentioned, ANSYS and design of experiment will be used. And as the setup on DOE, there will be 48 runs of simulation to achieve my FYP goal. and all the data will be referred to the Zabaras and Prof. Jamaluddin papers. Methodology will be 4 stages, which is convergence and numerical validation for stage 1, setting up case study using design of experiment for stage 2, and stage 3 is failure analysis. For stage 4 is applied for the arranging of the FYP result, which will be optimization using response surface method RSM. For merge convergence analysis is to determine which minimum mesh size that give a stable result when load is applied to the material. As shown, 8x8 and bigger size give a stable result, which is the material will deform at 0.0001 meter. In numerical analysis, it will be 2 methods used, which is normalized displacement and stress of composite laminate and failure criterion. The parameter used for both methods is same, which is full square plate, which is 1 meter length, graphite material, and symmetry cross-ply 0.9090 of lamination scheme, which 0.005 per ply. In this case, simply supported boundary condition is used. The data received from the ANSYS will be converted into normalized value before compared to Zabaras and exactly elastic value. Overall, as the error percentage do not too huge, it is considered this method is acceptable. Value of ANSYS software is in unnormalized, therefore it needs to be changed into normalized value using this equation, such as normalized deformation, normalized stress and strain value. For the failure criterion, my result is compared with Prof. Dr. Jamaluddin data. Moreover, failure criterion will be my objective result that I need to discover later on. So, failure criterion is to estimate the failure of composite material. The material is considered fail if the value of fail index is approximate 1. In the graph is the value of the load applied that caused the composite material fail versus the aspect ratio. The expected result is to show that the percentage error is not too big if compared to other data. As I showed before, I compare it with Prof. Jamaluddin paper. The percentage is still below 15%. Same in this result, I will show the curve comparison of hybrid composite laminate failure curve from the previous study. From this result and output, it can be understand their failure behavior related to the parameter stated before in scope and limitation in my FYP study. Related to the result, I have obtained all my future results will be approximate with previous research data and exact value by using this computational method. So here is my expected data, and it is presented in the table method that consists of the load that caused the material started to fail. Then there also a chart presented as comparison between first fly failure and last fly failure of the lamination composite material. So that's all from me for my FYP proposal presentation. If I can provide you with any further information regarding to my final year project, please let me know. You can contact me through the provided information here. Thank you for lending me your ears.